All right, so good day, class. So for this week, the prelims, let's look at a project case analysis of the London Heathrow Terminal 5 project. So this is one of the uh, writings that I submitted when I was studying for my master's, my postgrad diploma in project management at the University of Liverpool. So let me read this. So, so in this technologically innovative era, mega projects are being built on a global scale as each country aims to improve its service to its citizens and showcase its economic clout. So mega projects are defined to be investments of 1 billion US dollars or more, but organizations who are responsible for its conception and implementation often face a term called performance paradox. Even if mega projects are filled with opportunities for learning and improvement, they consistently have poor performance records, like the case of the Denver International Airport. But today, we're going to analyze the essential factors and components which made the London Heathrow Terminal 5 succeed as a mega project. So first, we will discuss a brief background of the T5 project before dissecting its components. So the planning stage of the T5 began in 1986 and had the longest public inquiry in the UK's planning history from May 16, 1995 to March 17, 1999. It's important to note that it was only on November 20, 2001 where consent to proceed for its construction was approved. From the viewpoint of an architect like me, planning, conceptualization, and preparation of blueprints are crucial factors for project success because mistakes can be easily identified in the early stages while still on paper and be corrected with ease. So Davis, Gunn, and Douglas identified single model environments which simulate electronically and virtually the finished outcome of the project. So simulated models of the project can be achieved through programs like SketchUp, AutoCAD, and 3D Studio Max. They allow you to see in real time what the project will look like in its final stages and identify the project element which needs focus and attention. So this is a technique I had been using since I became an architect, and it proved to be valuable even with the current organization I belong today. So on a higher level, these simulated models can be placed on simulated environments which mimic temperature, climate, and energy consumption. So examples of this software like this include IES, Ecotech, and some Ruby plugins in SketchUp. So they allow you to analyze the sun path, observe shadow patterns, and recreate weather data. Crucial flaws in the design are identified as early as in the conceptualization. So the design phase for the T5 began in 1982 when the renowned architect Richard Rogers won the national competition. So it is important to note that he used an approach called progressive design fixity, wherein three different designs were developed to meet the changing needs of the client, taking into consideration events like the 9/11, which made a lot of impact on the stage. So this allowed for crucial changes and developments in the blueprints of the T5, which would later contribute significantly in its success. So Norman Hayes, the first project director of the T5, recognized that many projects fail because of insufficient investment in the design phase. And he said, when you achieve your biggest wins, you're never going to achieve them during the construction phase. So the construction phase had two subphases. The first was the construction of infrastructure and buildings. The second was the integration of systems and retail fit-out of the buildings, which began early 2006. So the logistical challenge, excuse me, was having only one main entrance to the site, having limited space for storage, and being adjacent to one of Europe's busiest motorway. This was solved by BAA by using pre-assembly and prefabrication techniques to enable suppliers to assemble, manufacture, and test components before they are taken to the site. 70% of overall mechanical and electrical engineering modules and components were manufactured and assembled off-site. So the operational readiness phase, which involved a soft opening for the T5, experienced difficulties during its opening on March 2008. This cost BA around 31 million US dollars in the first 5 days, and 501 flights were cancelled. So the aftermath of the troubled opening would make it easy to identify T5 as a mega project failure. However, Davis Gunn and Douglas research suggests there is much more to learn from the innovative approaches in the T5. They identified a hierarchical model and presented operational success, project processes, and project governance structure as its core components. At the top of their model is the systems integrator, who is responsible for the governance and management of the mega project throughout its phases in the project lifecycle. The systems integration with essential tasks and activities learned from the T5 project was the implementation of new radical approach of a novel type cost plus incentive contract called the T5 agreement, wherein the client pays the contractor the incurred cost plus the profit margin. So it is different from other cost plus contracts because BAA assume full responsibility for the risk and work collaboratively with integrated project teams and first-tier suppliers to create innovative solutions. So fixed price contracts may work well in routine capital projects where risks are known and understood, but it falls short in the case of mega projects. So as to the recommendation of the authors to abandon the idea that all projects are unique, it is because they determined that the processes involved can be progressively standardized, simplified, and repeated through a method called system recombination and replication. So I agree with the authors because in the case of construction projects, there are certain processes which can be repeatedly implemented. Much can be learned from project experiences to create replicable processes. Okay. So let's continue. So the analysis on the importance of planning in organizations. So this is still related with the T5. So to better understand what makes projects succeed and fail, it's important to determine first the things which needed to be done at the start of its conception. The focus should be the development of strategic objectives which are aligned and reinforces the organization's goals. It is also determined that the senior manager and key stakeholders be present during the project launch meeting as a symbol of their commitment to the project. It is in this meeting, even according to my experience, is where the PM can make a psychological impact to the stakeholders and the project team. The details and requirements of the project should be put into writing during this activity. So in the presence of everyone involved in the undertaking, so that expectations of the project are clear and the major risks reviewed in the meeting. It is important to note that unless expectations are properly identified during this stage by all parties, the planning process has a tendency to be misguided. A much more practical way to understand the importance of planning is to study a successful project like the London Heathrow Terminal 5. So mega projects are undertakings with an investment of $1 billion or more, of which organizations handling these projects often face a performance paradox. So even with poor performance records of these gigantic undertakings, the T5 stood out amongst other mega projects. So to answer the question, what made the T5 successful, let's go back to re-examine the British construction industry during its time. So during that period, the construction industry ambience carried an adversarial approach in handling contracts. Companies were suing each other, thus taking much time and resources from all parties involved. BA recognized this problem and carried a different approach in its contract. They initiated a relational contracting strategy called the T5 Agreement, which considered its contract parties as partners in achieving its objectives. So another way was to emphasize on planning, which was the longest in the record of the UK. This allowed ample time by the identification and mitigation of possible risks of the project. Another thing they implemented was the development of SMEs or simulated model environments. This allowed the stakeholders in project team to gain a 3D view and perspective on how the project will look like in the final stages and what are the possible design flaws. So in my experience, we make SMEs to determine the look or locate the possible sources of conflict in the design. So I think class a good way to simulate models right now is to use building information modeling or BIM. So we also utilize SMEs to determine the performance of building in times of earthquake and in achieving green designs. The T5 management also never forgot their social responsibilities to the project team and everyone involved in the project as they were given the best possible treatment and accommodation for the project. So it's important guys that you recognize that those involved in your project team, your future staff, they're not just names on a spreadsheet. So they are human beings and people. So you should learn how to manage them well. Because if you know how to work properly with the people around you, then they will also help you out. So as a conclusion, it's important to note that failure to plan leads to wasted effort, lost time, and increased cost. Good planning practices require a stable line of communication between stakeholders and the project team. The project manager is expected to provide strong leadership so that the project objectives are met in line with the organization's objectives. So this is for this week task. I'll post our activity for this week for our prelims at our Padlet link. So if you have any further questions or clarifications, you can send an email anytime. Okay, so see you next meeting.